Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the system of equations x squared plus y squared equals 7 over 3 and x cubed plus y cubed equals 3. Quadratic cubic systems can be quite difficult to solve and becomes quite lengthy and messy in many cases, but in here we have sort of nice numbers right here so that the solution becomes relatively simple. Not too simple though, just reasonably simple. So let's get on to it. This is the type of problem that so-called x plus y and xy method have huge merit. That is, instead of solving for x and y, we try to solve for x plus y and xy. Here, let x plus y as s and xy as p because sum and product. Then once we find the values of s and p, values of x and y can be found by solving the quadratic equation t squared minus st plus p equals 0. So let's do that. We can convert the given equations using following famous formulas. Then we have, first, s squared minus 2p equals 7 over 3. Let's call this equation 1. And s cubed minus 3sp equals 3. Let's call this equation 2. From equation 1, solving for p gives s squared minus 7 over 3 divided by 2. So p equals 3s squared minus 7 divided by 6. And let's call this 3. Substituting this into equation 2, we have s cubed minus 3s times 3s squared minus 7 over 6 equals 3. So we have 2 here. So by multiplying 2, we have 2s cubed minus s times 3s squared minus 7 equals 6, which rearranges to s cubed minus 7s plus 6 equals 0. So we have cubic equation. Luckily, the numbers of this problem are nicely given so that this cubic equation can be easily solved. You can easily notice that s equals 1 is a root, so s minus 1 is a factor. So s minus 1, and if we do the division, we obtain s squared plus s minus 6 equals 0, which can be further factored into s minus 1 times s minus 2 times s plus 3 equals 0. So s equals 1, 2, and minus 3. And using this equation 3, we can obtain values of p, which gives s comma p equals, when s equals 1, then p equals minus 2/3, and when s equals 2, then p equals 5 over 6, and when s equals minus 3, then p equals 10/3. So we have obtained s and p, and now it's time to find x and y. Since x plus y equals s and xy equals p, x and y are roots of the quadratic equation t squared minus st plus p equals 0. So first, when s equals 1 and p equals minus 2/3, then x and y are roots of the quadratic equation t squared minus t minus 2/3 equals 0. So 3t squared minus 3t minus 2 equals 0. And using the quadratic formula, we obtain t equals 3 plus minus square root of 33 divided by 6. So x comma y is given as 3 plus minus square root of 33 over 6, comma 3 minus plus square root of 33 over 6. Of course, plus minus and minus plus signs means that if one root takes plus sign, then the other takes minus, and vice versa. Now let's move on to remaining two cases. When s equals 2 and p equals 5 over 6, then x and y are roots of t squared minus t plus 5 over 6 equals 0. So 6t squared minus 12t plus 5 equals 0. So the quadratic formula gives t equals 6 plus minus square root of 6 divided by 6, which means that x comma y equals 6 plus minus square root of 6 over 6, comma 6 minus plus square root of 6 over 6. Finally, when s equals minus 3 and p equals 10 over 3, then we have the quadratic equation t squared plus 3t plus 10 over 3 equals 0. So 3t squared plus 9t plus 10 equals 0. Then we have t equals minus 9 plus minus square root of 39i, the imaginary unit, divided by 6. So x comma y equals minus 9 plus minus square root of 39i over 6, comma minus 9 minus plus square root of 39i over 6. So we have two pairs of imaginary roots. Therefore, combining all of these cases, all possible roots are 3 plus minus square root of 33 over 6, comma 3 minus plus square root of 33 over 6, 6 plus minus square root of 6 over 6, comma 6 minus plus square root of 6 over 6, and minus 9 plus minus square root of 39i over 6, comma minus 9 minus plus square root of 39i over 6. So we have 6 pairs of roots, 4 of them are pairs of real roots, and 2 of them are pairs of imaginary roots. And that's all for today's video. Thank you for watching. Please don't forget to hit the like and subscribe buttons if you enjoyed this video, and I will see you in another video.